Okay, so today we are going to look at some topics left from opamp. These topics may not be important from the point of view of solving opamp circuits, but uh, this is very vital information, and I may not be able to touch them in very much depth, but I will try to explain them at least as much as the book does. So the first topic that I am picking to teach today is the negative feedback. Why do we need negative feedback? Now remember that an op-amp is not such an amplifier that if you apply some input, you get the output multiplied by some fixed gain. So the output is A times Vi as we expect. But an op-amp is manufactured such that the useful gain that we want in circuits, for example, in an inverting amplifier, we like VO to depend not on A but on external elements that we can change and control the A. So, so uh, here the output depends on this A. In the open loop configuration, there is no feedback, but when we use a feedback based circuit and a negative feedback, in fact, the output does not depend on A any longer. We have seen that earlier in the discussion of ideal op amp and the practical op amp. But why do we do this? The question is, why not have an op amp in open loop configuration and have such type of relationship between the output and input? The problem here is this A. This A, which the op amps are manufactured, are usually very large values. So they are very large values. But this is not the problem. The problem is they are so much dependent on several factors. For example, they are dependent on temperature. They are dependent on the manufacturing process, and they are dependent on other factors as well, say the material that is used in the construction of the op-amp. So if the temperature changes, for example, a device that is using an op-amp is being operated in a temperature of say minus 21 degrees centigrade, this A has a different value. So for example, for mu A 741, the typical A is said to be 2 into 10 raised to power 5. But this is a typical value. The manufacturer claims that it is a typical value. On average, this may be the value of the op-amps manufactured by that manufacturer. But in reality, it is dependent on temperature. So at minus 21 degrees centigrade, it may be a very different value from this one. And at say 65 degrees centigrade, it may be a very different value from this one. So if A varies so much that we cannot reliably, reasonably predict what would be the output at a certain time. So this basically changes the whole thing. We don't like random things in our circuits. We want to be deterministically be able to find the output of our circuits. So this A is very much dependent on a lot of factors, and it can vary a lot. Even the A of the same device can vary, same op-amp can vary, and from that same manufacturing process, the various op-amps that are being produced in hundreds all can have different A's. So how would it sound to have uh, an op-amp for which you don't know what the actual A is? We cannot reliably use them in circuits and say, okay, this is the input and we are going to get this much output, and that too will change. So this problem is being rectified by the use of negative feedback. So what we do, although this is not a real depiction of how negative feedback um, could be explained to you, but we know that in reality what we do, we take a part of the output, we take output and take a part and feed the input with it. So there is this input signal as well, and then there is a part of output coming to the input as well, and this is always connected to this negative or the inverting input pin. That is why it is known as a negative feedback, because by connecting the feedback to this pin we are actually taking a part of the output voltage and destructively adding to the input, or in other way we are subtracting the input with a part of the output. So it is not the input that is being amplified, it is the input minus a part of the output. So what happens? So if now the A changes, so the A was different value, at a different temperature, and it reduces the output or increases the output. But now in this negative feedback configuration now, if the output increases because of changes in A, then this part being fed back changes as well. So if this increases, this part increases as well. So input is reduced. So A is trying to increase the output, but the reduction in what is being amplified basically reduces the output, or it does not allow the output to change very much. So in this way we get output that is not dependent on A, and this is a big achievement. So in having a circuit that does not depend on A, we have we have distanced ourselves from all these details. What will be the ambient temperature, from which manufacturing process it has come, what material has been used, what is exactly the value of A. We do not consider that anymore. All we know is A is a high value, and the gain of the system that we are interested in is not dependent on that A, but the external element values that we have chosen. So this is the purpose of of negative feedback. Feedback can be positive. Feedback, a positive feedback example can be, say, a microphone. So somebody has a mic, and he points it to a speaker. So there is a speaker, and there is a microphone, and the microphone is directed towards a speaker. So this microphone signal gets amplified and then played on the speaker. The speaker plays an amplified signal or whatever the microphone is feeding this amplifier. So this the output of the speaker, the loud sound that we have, will be will get caught in this microphone again. This will send a larger signal to the amplifier, and it will produce a further larger output, and it will pick that larger output again. And this is an example of a positive feedback. Every one of you might have been might have come across speakers that shriek or um scream, and that is basically because of some setting in which they get in a positive feedback loop, and you have to disrupt the microphone or something else to stop that screaming. So positive feedback is not very useful because it results in unstable systems, as we can see in the example of the microphone and the speaker. So if initially a very small signal is being fed here, it gets amplified, and that amplified signal is then kept and further amplified, and in this positive feedback ultimately it's a scream or unstable system. Whereas for the case of a negative feedback system, part of the output gets to the input and reduces the input. So if VO wants to increase because of some increase in A being a parameter or characteristic of this op amp, for this amplifier, then that output, that larger output, will make this feedback part larger, further reducing the input. And this reduction of input basically is going to reduce the VO, and it does not get affected that much. So this is why a negative feedback is used in op-amp circuits. Although we will come to one application where we will be using the op-amp without a negative feedback resistor. We will come to that later on.